Let's talk about the mean and the standard deviation of binomial probability distributions. A couple of sections ago, we talked about the mean and the standard deviation of a probability distribution, but we're specifically going to talk about the binomial probability distributions in this section. So let's look at an example. Let's suppose that you flip an unfair coin 5 times. This particular coin has a probability 0.6 of landing on a head. That's why we call it an unfair coin. A fair coin would have a probability of 0.5 of landing on its head. So our unfair coin has a higher probability for heads. Create a probability distribution for the number of heads that could result with 5 flips of this unfair coin. This is the kind of stuff we were doing in the very last lesson. So if we were to do that, this is a binomial distribution. We have one of only 2 outcomes, heads or tails. We have a fixed number of trials, 5 trials. We have every trial is independent. Flipping a head on one is independent of what you flip on the next one. And the chance of success, flipping a head, is the same, 0.6. So we would use the formula we were doing last time. Let's see, n would be our number of trials, that will be 5. X is the number of successes. That would depend on what our random variable is. Here we go. X could be 0 heads or 1 head or 2 heads or 3 heads. And P would be the probability of success, so that's 0.6 for getting a head. Q would be the probability of a failure or a tail. That would be 0.4, 1 minus 0.6. So if we went through and we did this P of X 6 different times, so P of X equals 0 and P of X equals 1, just like we were doing in the last section, we would get all these probabilities on the right-hand side. Now, let's kind of tie that problem that we worked on last time with the problem we worked on 2 lessons ago. Finding the mean of this probability distribution. Now what we did 2 lessons ago was we had this formula for finding the mean of a probability distribution where we took each random variable x and we multiplied it by its own probability and we added all those up. But we're in a binomial probability distribution, so we have a shortcut formula. It's awesome. The mean for a binomial probability distribution is simply n times p. The number of trials, 5, times the probability of a success. Furthermore, the standard deviation, sigma, of this binomial probability distribution, we did use the previous formula, which is admittedly kind of a nightmare for finding the standard deviation, if it's a binomial. So remember, either a success or a failure, only 2 possible outcomes, not more than 2. So only if it's a binomial probability distribution, we can use this shortcut formula, n times p times q. So 5 times 0 times 0.6 times 0.4, which is 1.095. Okay, let's suppose you flip an unfair coin 8 times. The probability that this coin lands on a head is 0.3. Find the mean number of heads expected in 8 flips, and find the standard deviation of the probability distribution. So we're going to use our lovely formula, our new great formula for binomial probability distribution for the mean, n times p. So that will be 8 coin flips times the probability, 0.3, and we have a standard we have a mean of 2.4. Standard deviation is going to be the square root of n times p times q. So for this one, it will be the square root of 8 times the probability of a success, 0.3, times the probability of a failure, 1 minus 0.3 or 0.7, and we're going to get 1.296. Okay, Range rule of thumb. Again, don't forget this was the maximum usual value is the mean plus 2 standard deviations. And the minimum usual value is the mean minus 2 standard deviations. In other words, most values of our probability distributions fall within 2 standard deviations of the mean. So for example, let's suppose that we flip an unfair coin 8 times. The probability that the coin lands on a head is 0.6. Find the mean number of heads expected on 8 flips and the standard deviation of the probability distribution. And then we'll find the maximum and minimum usual values. So the mean, because this is binomial, is just n times p. So 8 times 0.6, which is 4.8. The standard deviation is the square root of n times p times q. So n is 8, p is 0.6, q is probability of a failure, 1 minus 0.6, so 0.4. And when we do that arithmetic, we get 1.39. Okay, maximum usual value. We'll start at the mean and go up 2 standard deviations. So 4.8 plus 2 times 1.39, or 7.58. And the next example, the minimum usual value is left for you. Let's do another example. Let's suppose that you flip an unfair coin 8 times. The probability that this coin lands on a head is only 0.1. Find the mean number of heads expected on 8 flips and the standard deviation of the probability distribution, and then the maximum and minimum usual values. Okay, so using the formula again, the mean is n times p, so 8 coin tosses times the probability of a success. So 0.8 is the mean. The standard deviation would be the square root of n times p times q. So 8 times 0.1 times 1 minus 0.1, or 0.9, we get 8.849. The maximum usual value would be the standard deviation, 0.8, plus 2 sigma, to get 2.48.